Hello, thank you for joining us today. Our team, St. Anchormould, was tasked with creating an educational engineering tool for the use of the Tumaini Innovation Center and its students. Our solution was designed to be understandable, able to scaffold to attain different levels of difficulty, resource effective, and useful to the community surrounding the Tumaini Innovation Center. This is an incredibly vital undertaking because the Tumaini Innovation Center grooms future engineers of Kenya, who will then be able to work towards the improvement of living conditions and the implementation of technology that will drastically improve the quality of life of the people of Kenya. The solution that we created for this educational project is called the HyperStation. The HyperStation is a hyperlocal network of weather stations in a small vicinity that will be able to connect to your smart devices and feed you live data of weather right outside. Now, please join us as we explore the specifications of the HyperStation.
The HyperStation is based on an Arduino microcontroller. We have here an Arduino connected to multiple weather stations that feed it data. We also have a Wi-Fi module connected to the Arduino. This allows the Arduino to connect to nearby Wi-Fi servers. Over here, we have a Raspberry Pi serving data to this laptop. The Arduino can connect to the Raspberry Pi via Wi-Fi, and we are then able to use any device with internet connectivity to connect to the Raspberry Pi and get live weather data easily. Keep in mind, however, that this is the maximal version of our solution. We are also able to remove the Raspberry Pi element of the solution and make it a simple, centralized weather station that displays the weather data on an LCD connected to the Arduino directly.
This makes the HyperStation very understandable as students can start by building a simple centralized station and then increasing the complexity of their work until they're able to produce a hyperlocal network. Furthermore, there are many lessons about coding and programming that could be incorporated into the teaching tool. One such lesson could be that the students are given broken code for an Arduino sensor that they must debug in order for the HyperStation to work. The HyperStation is extremely simple to scaffold. One can use any kind of Arduino-compatible weather sensors, and again, the Raspberry Pi element of the solution can be removed by plucking a few cables. Additionally, the project is very resource effective. One unit of a HyperStation, which includes one Arduino, Raspberry Pi, the weather sensors, cables, breadboard, and one LCD, should cost around $70 USD. Finally, we designed the HyperStation to be beneficial to residents near the Tumaini Innovation Center by giving them easy access to current weather conditions and metrics that they can understand.
The HyperStation is the best method of furthering the Tumaini Innovation students' understanding of Arduino application because of its effective ability to scaffold and to accommodate vast differences of skill level that may exist between Tumaini students. It is also designed with materials that are readily available to the Tumaini Innovation Center in mind, which should mitigate the initial cost of teaching and implementing the HyperStation. We believe that the HyperStation will be a valuable tool for teaching students of all levels about electronic technology, both in software and in hardware.
For the HyperStation, we are assuming that this solution provides data that is useful to both the students and community of the Tumaini Innovation Center, and that the Tumaini Innovation Center is able to provide students with all of the technology necessary to implement our solution. One of the largest drawbacks of the HyperStation is that all of the data is transmitted over a short range because it is sent over Wi-Fi. Other weaknesses are that the Raspberry Pi can only handle so many web clients at once, and that the Maximal solution is fairly complicated. So it is possible that some of the students will not be able to benefit from learning about the Maximal solution.
In summary, the HyperStation is both a valuable teaching tool and community asset that will be very beneficial for the Tumaini Innovation Center and its neighboring residents. Its resource effectiveness, scalability, and general usefulness to the community makes it the perfect teaching tool for the Tumaini Innovation Center. Students will be able to learn the technical aspects of the HyperStation and will learn more about community outreach and implementation if they choose to put the HyperStation to real-world use.
Thank you so much for your time and have a blessed day. Asante.